Good morning. Okay, so a block of mass 2 kg is pushed against a rough vertical wall with a force of 40 Newton. A block of mass 2 kg. This problem, many students fail to understand this. Okay, let me explain what is this now. So what the way how they do it. Okay, then I'll go to the right way. The block of mass 2 kg is pushed against a rough vertical wall. You keep a mass here of 40 kgs with a force of 40 Newton. With a force of 40 Newton. Because it says it is pushed against the rough vertical wall. This is a rough vertical wall. You are applying a force like this. The coefficient of static friction being 0.5 because rough wall, so definitely mu equal to 0.5. Another horizontal force of 15 Newton is applied on the block in a direction parallel to the wall. Now, this is something which confuses all the students. Okay, so what they do is they either consider the force like this, 15 Newton, this is 2 kg mass. Okay, or they consider it like this. A few of them consider it like this because it is logic, so everyone understand that. Okay, so there's no need of pushing like this because this is sufficient. If you push it like this, definitely it will fall down. Because the next question is, will the block move? Okay, so definitely this cannot be the right answer. So if you say, okay, people generally think, right, okay, it's a crazy thing to give something like this. So this is what is the diagram which they make. But strictly speaking, there's something else here. Okay, this is not the right diagram. Let me show you the right diagram. The right diagram is here. Right. So 40 kg, 40 Newton is applied like this. 15 Newton is applied parallel to the wall. What did we do? Generally a student applies it like this, which is incorrect, right? So it says it is parallel to the wall in a horizontal direction. How do I know that it's being given here? Another horizontal force. See, if I apply it like this, is vertical force. Horizontal should be like this along the x-axis. Okay. So will the block move? Now let's see whether we can be able to do it or not. Now where is friction acting here? You apply, since it's a rough wall, okay, friction can act at everywhere, right? So therefore, now if you are applying a force 15 Newton here, and you are applying a force 40 Newton here, and you are also applying a force mg over here. What is the value of mg? Mg is nothing but m is 2 kg, this is 20 over here, 2 into 10, 20 Newton downwards. What we will do is, let us consider this 15 and 20. These are the applied forces. These are vertically applied forces. This 40 Newton is being counteracted by the normal force. Okay, otherwise this would have broken the wall. Not possible. So the normal force is now acting over here to give rise to 40 Newton. So let me write n equal to 40 Newton. We already got this. Now in addition to it, there are two more forces. Okay, because you see, when you have a block of mass m and you say you are applying a force F, frictional force will be opposite to this force. Will be opposite to this force. And if the object is sliding, then this will be equal to mu times m. If the object is not sliding, it will be opposite to or equal and opposite to this force. Now the sum of these forces, mg is acting like this, 20 Newton. I will not write this one here. Okay. So what has happened to this? Okay. So mg is acting 20 Newton, 15 Newton is acting like this. In other words, I can now write like this. This is my 15 Newton. And this would be my 20 Newton. This will be my 20 Newton. The sum of these two would have been like this over here. Now what is this value? This value would be square root of 15 square plus 20 square. What I will do is, because it's a right angle triangle, see, there's a right angle triangle here. So I will take 5 square common here. 5 square into 3 square plus 4 square. I'm not going to use any calculator here. Now this should now be equal to 5 square into 5 square, right? 3 square plus 4 square is 5 square, square root. Now I can say this is equal to 5 square itself, which is equal to 25 Newton. Which means what? This value is equal to 25 Newton. Now what we need to do? How does the friction act? Friction should act oppositely like this. Are you right? Okay, see? So you are applying a force here, you are applying a force here. Some of these two forces are acting like this. Some of these two forces are acting like this. Your frictional force should act like this, opposite to it. Now, if your frictional force is equal to 25 Newton, block does not move. Simple. If your frictional force is less than 25 Newton, this 25 Newton takes a dominance over it. And as a result of it, the block will now slide like this. Am I right? Now, how do I know what is this value of frictional force? The frictional force is nothing but mu times n. Okay. So threshold frictional force. Let us find the threshold frictional force. So this should now be equal to, what is mu? 0.5. What is n? N is already 40. So it should now be equal to 20 Newton. So which means until 20 Newton, the object is able to resist, or the friction is able to resist it, and the object will not slide down. But here you see, it is 25 Newton. Your applied force itself is 25 Newton. What happens? The block definitely slides, right? See, it's all about, okay, how to look at a problem. It is not something like it's very tough IIT level, nothing like that. Every problem is easier. You should know how to crack it. Okay. So with this, let me stop here. I hope you enjoyed this video. If you like this video, do like, share, and subscribe to my channel for further updates. And this will also give me more appreciation to continue with this. Thank you.